Hello and welcome back. In this video we'll finish up with one final example using our trig identities. So we're told that the cosine of some angle S is going to be 1/2, and we know that that's in quadrant 1. And we know the sine of some angle T is going to be 1/3, but that's in quadrant 2. So again, quadrant 1 is up in the right-hand corner, quadrant 2 is up here in the left-hand corner. And we want to find cosine of S plus T, and we want to find the cosine of S minus T. Well, both of these, the cosine of S plus T, we have a formula for that. And what do we need to know? We need to know the cosine of S, cosine of T, the sine of S, and the sine of T. We know two of them. We know the cosine of S and the sine of T. We don't know the cosine of T, and we don't know the sine of S. We know the other two, so we could just plug them into our formulas for these. So all we have to do is figure out the cosine of T and the sine of S, and we're golden. We can just plug them into our formula. We need to use this information. We need to use the information that we're given, cosine of S and the sine of T, to figure out the other one. And we've done this before. We did this in previous chapters. If we're given information about one trig function, we can find the rest. And I'm going to do this in a slightly different way than I had before in some of these videos. I'm going to use the Pythagorean identity. So for instance, if I want to know the sine of S, I know that the sine of S squared plus the cosine squared is going to be equal to 1. So I can solve for the sine of S here. The sine squared of S plus the cosine squared. Well, the cosine is just going to be 1/2, and that squared is going to be equal to 1. And then we simplifying this further. So 1/2 squared is going to be 1/4. So sine of S squared is going to be 1 minus 1/4 after I move that to the other side, which is just 3/4. And if I have something squared is equal to 3/4, I'll just take the square root of both sides. So the square root of 3/4 is going to be the square root of 3 over the square root of 4, which is 2. And the last thing is there are actually two roots here. We're going to have the positive root and the negative root, because if I square the negative one, the negatives will cancel out and I'll get the same thing. So should sine of S be positive or negative? Well, the cosine of S, we've said that the S angle is in quadrant 1. So we're up here. And I know that the sine of an angle is going to be x divided by r. And in quadrant 1, x, which is the x-axis, well, we're pointing to the right, so that's positive. And r is always positive, so positive divided by positive is positive. So we can get rid of the negative root. So we know that sine of S is just root 3 over 2. And let's play the same game with the other angle. We know that sine of T is 1/3. So if I take the sine of T and square it, plus the cosine of T and square it, that should be equal to 1. So here, sine squared, so that's going to be 1/3. So we'll have 1/3 squared plus cosine squared of T is 1. 1/3 squared is 1/9, so I can subtract that from both sides. So cosine squared of T is going to be 1 minus 1/9, which is 8/9. And then again, we can take cosine T, we can find that by taking the square root of both sides. So I've got the square root of 8, which can be simplified. I'm not going to for the moment. I'll do this at the very end. And then the square root of 9, which happens to be 3. And again, I have plus or minus. So is it the positive root or is it the negative root? Well, the cosine of any angle, I made a mistake before. The sine of an angle is y over r. And the cosine of an angle is x over r. So I made a mistake before, but it doesn't change anything. In quadrant 1, which is where I was doing this before, y is positive because we're going up, and r is positive, so sine is still positive. So it means that this guy, we still want the positive root. Hoofda, I made a mistake, but we made it correctly. The cosine of an angle is going to be x divided by r. So if I'm in quadrant 2, y is positive because we're going up, but x is negative because we're going to the left. So I've got a negative number divided by r, which is always positive. So I want the negative root. In quadrant 2, cosine is negative. So I want negative square root of 8 divided by 3. So we now know the sine and cosine of both s and t. So let's just use our formula and finish the question. So if I want the cosine of s plus t, this is going to be the cosine of s times the cosine of t minus, we flip the plus to a minus, sine of s, sine of t, and now we just fill everything in. Cosine of s, we said was 1/2. Cosine of t is going to be negative square root of 8 divided by 3, minus the sine of s, we said was root 3 over 2, and the sine of t, we said was 1/3. So now it's just a little bit of simplifying. So on the bottom of the fraction, we've got 2 times 3. Top of the fraction, we've got 1 times negative square root of 8. And then over here, we're going to subtract. On the top of the fraction, we've got the square root of 3. And on the bottom of the fraction, we've got 2 times 3. So again, bottom of the fraction, we have the same common denominator, so 2 times 3 is just going to be 6. The square root of 8, 8 is 2 times 2 times 2, or the square root of 2 times 4, which is going to be 2 root 2. And I've got a negative sign. Oops. So minus 2 root 2 minus the square root of 3. So this would be about as simple as I can make it. I think maybe the only thing that I might do is just pull out a negative sign and just say that it's 2 root 2 plus root 3 over 6, and we're making the whole thing negative. I think both of these would work. And let's do this the exact same thing for the cosine of s minus t. This is going to be, again, cosine of s, cosine of t, plus this time sine of s, sine of t. And the nice thing is everything is still in the same location, so absolutely nothing changes, except we're going to be adding this second fraction instead of subtracting it. So all the same work holds. So you've got this negative square root of 8 over 6 minus, plus, because we're adding this time, we're not subtracting, the square root of 3 over 6. And then this simplifies in nearly the same way. This will be negative 2 root 2 plus root 3 over 6. So again, the only difference here is, are we subtracting or are we adding? So there you go. I think there's a couple of questions like this on the homework. Good luck. If you have questions, email me, get in contact with me, and the sooner you do so, the more help I can get.